Exercise 1.4, question 3. The following real numbers have decimal expansions as given below. So you're given some decimal expansions. In each case, decide whether they are rational or not. So you just have to tell, are they rational, are they not rational? And then if they are rational and of the form P by Q, well, every rational number is of the form P by Q, then what can you say about the prime factors of Q? Well, there are two parts to this question. Let us first talk about this first part. You just have to tell whether they're rational or not. Let me just get to these numbers one by one. All right. Now, here is a page from your book. You already know that the decimal expansion of every rational number is only of two types. Either it is terminating or it is non-terminating, repeating. So let's see which ones here are either terminating or non-terminating, repeating. And as I said, this is the first one. So this one, if you see, is ending here after the 9, right? So when a decimal expansion just ends, then what kind is it? It is terminating. And just how we saw, every rational number has these two kinds, either terminating or non-terminating repeating. So this one is indeed a rational number. Then the second part makes sense. It said if they are rational and of the form P by Q, you don't have to write it in the form P by Q, but what can you say about the prime factors of Q? Now, this is something based on the previous questions that we've done. We saw what happens or when exactly a rational number of the form P by Q has a terminating decimal expansion. Well, if P and Q are co-prime, that is, they cannot be simplified any further, then Q, which is the denominator, should have a prime factorization of the form 2 to the power n times 5 to the power m, where n and m are non-negative. That means they're either greater than 0 or they're 0. They just cannot be negative. So that is what I can say about these. So that is what I can say about the denominator q here, about the prime factors of q, that they will only have 2's or 5's or both, no other prime factor at all. Let's look at the next part now. Okay, well, this one clearly is not terminating. How do I know? I know by these dots here at the end, it shows continuity. It shows that this is gonna go on and on forever. Let me see if there is something repeating. Why? Because I know in rational numbers, if it is non-terminating, then it has to be repeating. There has to be something that repeats. Now, before we go on, here's a little something we should talk about. If non-terminating repeating is rational, then what about non-terminating, non-repeating? Well, then it is not rational. That means in those cases, your numbers are going to be irrational. Now, that's all I have to see here. That is it repeating? Is it not repeating? Let's see. It is 2, 1, 2, 0, 1, 2, double 0, 1, 2, triple 0, 1, 2, 4 zeros, and so on. Okay, I get the pattern. But is there anything that's constantly repeating? No, there is a pattern. Yes, the pattern is that you just put 1, 2, and then you put a 0. And this number of zeros just keeps increasing. Here it was just 1, then it was 2, then you had 3, then 4, and so on. But this is why, because your number of zeros is constantly increasing, there is not a fixed block that is repeating. Therefore, this is not non-terminating repeating. What kind is it though? It is non-terminating, non-repeating. And that is why I can say it is not rational. That was part 1, right? Is it rational or is it not? So here it is an irrational number. So the second part of my question, if they are rational, that I don't have to do because that's only valid if they are rational. Let's now look at the final part, part C here. Well, what is this? I told you the bar means that these digits, this block of digits is going to constantly repeat, which means it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8 forever and ever. So yes, it will never terminate, and that is why I can say it's non-terminating. But this time, yes, it is repeating. What is the block that is repeating? Exactly the block that you see here under the bar. All of these digits from 1 to 8. And because it is this kind, non-terminating repeating, it is a rational number. Well, this time, what can I say about the prime factors of the denominator? Well, I know that if it is terminating, then the prime factors of Q are only 2's and 5's. So it's only 2's or only 5's or both. Otherwise, it's non-terminating repeating. That means the prime factors of Q can be other than 2's or 5's. Let me write this down. And we're done.